The James Webb Space Telescope discovers signs of another universe near the universe's edge. Is this the end of the Big Bang hypothesis? Is it implying that there is an entirely new world? Continue watching till the end to explore the mind-boggling consequences of this astounding discovery. The Big Bang is no longer the conclusion to the story. The groundbreaking James Webb Telescope has uncovered an incredible finding at the universe's edge, hinting at the presence of another universe. The James Webb Space Telescope has revealed a tantalizing clue at the farthest reaches of the universe, in a startling discovery that challenges our view of the cosmos. As scientists examine the data gathered by this cutting-edge telescope, a shocking possibility emerges, an enigmatic glimpse of another universe. This discovery upends long-held beliefs about the Big Bang theory and propels us into unknown territory, where the bounds of our known universe may be expanding, opening the door to an incredible realm beyond our conception. The tremendous ramifications of this discovery place us on the verge of a cosmic revolution, irreversibly altering our knowledge of the universe we live in. The James Webb Space Telescope is an infrared observatory that orbits the Sun approximately 1 million miles from Earth in order to uncover the first galaxies that formed in the early universe and to study stars developing planetary systems. From the first brilliant glows following the Big Bang to the creation of solar systems capable of supporting life on planets like Earth, as well as the evolution of our own solar system, Webb will look into every stage of the history of our universe. The findings produced by the Hubble Space Telescope will be furthered. The JWST, which is now fully operational, has 7 times the light-gathering capacity of Hubble, but will be able to see much further into the infrared region of the spectrum, revealing galaxies that existed even earlier than Hubble, thanks to its longer wavelength capabilities and significantly lower operating temperatures. Galaxy populations should be abundantly discovered before the epoch of reionization, and Hubble's previous cosmic distance record has already been broken. Using a portion of the previous Hubble Ultra Deep Field image, Hubble Extreme Deep Field was constructed over the course of 50 days and more than 2 million seconds of total observing time, or the equivalent of 23 full days, a record that stood until JWST shattered it. The XDF combined photons from ultraviolet through visible light and out to Hubble's near-infrared limit to depict humanity's deepest view of the cosmos. The JWST's JADES survey found the farthest distant galaxy to date, JADES GSZ 13-0 in the red box, where Hubble cannot see any galaxies. By extrapolating from what we see to what we know and expect to exist, we deduce that there are a total of 2 sextillion stars in the observable universe. JADES GSZ 13-0, whose light travels to us at a redshift of Z equals sign 13.2 and a time when the universe was just 320 million years old, is the new cosmic record holder for most distant galaxy, as shown in the annotated rotating image from the JWST Advanced Deep Extragalactic Survey. Despite the fact that we are seeing galaxies at farther distances than ever before, these records will probably be surpassed when additional coincidentally aligned gravitational lenses are found, as well as when the JWST is used for longer observing periods. The JADES and JWST NIRSpec spectra for the 4 most remote galaxies that the JADES scan has so far found. The Lyman break characteristic, which has been consistently discovered for each of the 4 galaxies, solidly supports the distance and redshift, making JADES GSZ 13-0 the most distant galaxy in the universe at the moment. A group of radio telescopes is called the Atacama Large Millimeter Submillimeter Array. The array has a resolution equal to the distance between the dishes, but a light-gathering capacity equal to the total of the individual dishes' collecting areas, as well as infrared fingerprints released at enormous distances and red-shifted within ALMA's sensitivity range. It can discriminate between molecular signatures that absorb or emit at long radio wavelengths. Even in the farthest galaxies, it obtains resolutions high enough to map out gas and gas properties. Due to its views that go beyond the boundaries of infrared astronomy, but are sensitive to spectroscopic fingerprints, ALMA can discover some of the most distant ionized excited materials in cosmic history. Based on the distance corroborated by ALMA, Galaxy GHZ2/Glass Z12 is found to be one of the brightest, most UV-rich galaxies from the early universe, as well as one of the most distant ones yet detected. Despite all we now know about our universe, many existential questions remain unanswered. Our universe must be bigger than the area that we can see, but we don't know if its size is finite or infinite. Because we lack sufficient data to draw a definite conclusion, we are still unsure of what transpired during the fiery Big Bang's first tiny fraction of a second. The universe has an advantage though, not in terms of distance, but rather in terms of time. There is an edge to how far away we can see because the hot Big Bang occurred at a known finite point in time. There is a fundamental limit to how far in the past we can see, even at the greatest cosmic speed limit, the speed of light. We can see further into the past if we look farther. Recently, when sorting through early JWST data, a group of astronomers made an intriguing discovery. They found 87 galaxies, some of which were so redshifted that they may have formed among the first galaxies following the Big Bang. Astronomers are having a difficult time interpreting deep field images taken by the James Webb Space Telescope during its initial observation campaign, which appear to be scattered with galaxies almost as huge as the Milky Way and full with mature red stars. The area of the sky covered by this image, which was taken by the James Webb Space Telescope, is barely 2% the size of the full moon. It contains thousands of far-off galaxies. Nearly a billion times fainter than what the human eye can see are the image's most minute objects. This image is categorized as a medium-deep, wide-field shot. Almost 13.5 billion years have passed since the light from the furthest galaxies arrived here. Frequencies of light tend to stretch towards the redder portion of the visible light spectrum as the light-emitting source moves away from the spectator. Simply, the older the source of a light appears, the more red it appears. Scientists are constantly searching for other red lights in the universe, much to the dismay of any therapist. The problem was that the red shift of the oldest bodies was so great that it leaked into the infrared spectrum. Unfortunately, the Hubble Space Telescope, which Webb replaced, was unable to do this. These galaxies, which were discovered in a recent study using Webb's initial data release, are so far away that the large telescope can only make out small crimson spots of them. Webb's observations were examined, and it was discovered that these galaxies were created only 200 to 400 million years after the Big Bang, when the universe was still very young. The stars in the Webb images identified galaxies were far too old and amazingly big. The surprise findings also go against earlier findings made by Webb's less potent predecessor, the Hubble Space Telescope, on how the cosmos originated and evolved in its early years. Young stars typically emit a brilliant blue light. As stars get older, their glow gets redder as they cool and burn through their fuel. Old red stars in the distant galaxies that Webb was intended to view were not what astronomers had anticipated to see. Additionally, they did not expect to see galaxies bigger than a billion suns. Leja claimed that the reddish blotches in Webb's deep fields looked to be 50 times bigger. Leja advises astronomers to confirm the weird red dots they are seeing aren't anything else before rewriting cosmology theories to explain how these galaxies came into being so quickly after the Big Bang. Leja claims that the majority of the potential solutions, however, call for entirely fresh ideas. The images of these puzzling galaxies were taken by Webb's near-infrared camera as part of the Cosmic Evolution Early Release Science Initiative. In order to obtain the light spectra of such far places, astronomers want to send Webb's mirror back to these galaxies soon. Spectra breaks down observed light into its constituent wavelengths, giving the chemical and physical characteristics of its source. But the universe has many edges, including the borders of transparency, stars and galaxies, neutral atoms, and our cosmic horizon from the Big Bang. If you like to know about the wonders of space, be sure to hit the subscribe button. Even though the Big Bang theory is no longer a thing, the discoveries still hold our attention. We are now tantalizingly near to learning the secrets of an additional universe at the edge of our own thanks to the groundbreaking discoveries made by the James Webb Telescope. There is still so much to discover and comprehend about the vastness of the universe. Want to know more? Then check out the end screen video where we discuss more about the Webb Telescope's findings. All right then, thank you for watching.